Wind. It unfurls our sails, powers industries, and carries tired travelers along their journey. But how do winds affect the circulation of water in the nation's largest estuary, Chesapeake Bay? Imagine you're a particle riding the wind. Below, the bay bears the marks of a drowned river valley with broad shoals flanking a central channel. It is relatively shallow considering its great size. The unique geometry of Chesapeake Bay means that winds can significantly affect how its waters move. Wind patterns over Chesapeake Bay can be very complex. The estuary's response to these winds can be equally complex. The transfer of momentum from air to sea and how that transfer develops currents, waves, and turbulence within the estuary is a process in which each phase is interdependent with the other. Resolving these processes has important implications for habitat restoration, navigational safety, and coastal forecasting. Chesapeake Bay suffers from chronic summertime low oxygen levels induced by high nutrient loading. This annual dead zone is maintained by a combination of biological and physical factors. Wind can drive currents which transport oxygen-rich surface waters from the shoals towards the deep central channel where the dead zone is typically most severe. These currents are dependent on wind direction, wind speed, and the physical conditions of the estuary prior to the wind event. Through a combination of observations and numerical modeling, scientists seek to address the many questions surrounding how winds affect Chesapeake Bay. Studies are currently underway, though there are still many questions left unanswered. But it is becoming clear that like rich sailing traditions and great migrations, wind is an important part of Chesapeake Bay's story.